Okay, one last couple examples to help us out in terms of using this square root property. Now, in this case, we can end up with some really odd looking answers, but they still count. Let's try this one. We've got t minus 1/4 squared minus 32 is equal to 0. And yeah, we could square t minus 1/4 and then figure out what's going to happen if we are able to factor, but it's not even necessary for us because, in fact, we do have a problem that is of the form u squared or a squared minus 32 is equal to 0. And this is the type of equation where we can move our constant over and take the square root of both sides, regardless of the fact that instead of a single monomial squared, we actually have a binomial squared. So here's how this would work. I'd add 32 to both sides, in my case. So I'd have t minus 1/4 quantity squared is equal to positive 32. And then by taking the square root of both sides using our square root property, we eliminate the square on the left-hand side of our equation to get t minus 1/4 is equal to positive or negative the square root of 32. And that can be reduced. Square root of 32, remember, I'll just take this off to the side, square root of 32 is a expression that has 16 times 2 under the radical. 16 is a perfect square of 4, so it's the same as saying 4 times the square root of 2. So, if we know how to reduce that in our expression, we would get t is equal to 1/4 plus or minus 4 times the square root of 2, which I know is an awfully odd looking answer, but in fact it is two solutions. T equals 1/4 plus 4 times the square root of 2, and t is equal to 1/4 minus 4 times the square root of 2. Okay, so this is two solutions. We could actually find these numbers if the next step was to write them in decimal form. That would be fine, but we're going to leave them in this form right here with the radicals. So we say leave these solutions in exact form, right? When you see the words exact form, having the radical is a lot more exact than having the decimal. Square root of 2 is an irrational number, remember, so we can't actually have a exact decimal approximation, only an approximation to this number. All right, let's try it with this one. 5 times the quantity x plus 4 squared plus 7 is equal to 17. Well, our first job here is going to be to isolate the quantity x plus 4 squared. So that means doing some subtraction. 5 times the quantity x plus 4 squared. Subtract 7 from both sides to get 10. And then we need to divide both sides by 5. And the reason we need to do that is that we need to make sure we isolate the part, that the variable or variable expression that is being squared to one side and all the constants to the other side of our equation. So here we go. X plus 4 quantity squared is equal to 2. Now we can take our square root on both sides to get x plus 4 would be equal to positive or negative the square root of 2. And then finally, taking negative 4, adding negative 4 to both sides would give us x is equal to negative 4 plus or minus the square root of 2. And that's two solutions in this case again. X equals negative 4 minus the square root of 2, and x equals negative 4 plus the square root of 2. In WebAssign, in fact, you will be answering your questions this way. Okay, good luck on the homework this week. I'll see you in class.